So good morning once again, and let's start today's class. Today we will learn Pitot tube. And this tube, what is use of this tube first of all? It is used to measure the velocity of flow in the river. Okay. It is used to measure the velocity of flow in the river. Okay. It is used to measure the velocity of flow in the river. Now, what is the principle on which it is working? Principle of this Pitot tube. If the velocity of flow at a particular point, if velocity of flow at particular point is reduced to zero, which is known as stagnation point, the pressure there is increased increased due to conversion of kinetic energy into pressure energy. Okay, so how this principle is, let me explain. First, we will draw the diagram of this Pitot tube. This is just like a L tube. And now let us assume that we dip this into the river. Okay, this is a river. In which water is flowing. Now this water is flowing in this direction. Let us assume that this point is A and this velocity is V, that is reverse velocity. Now, obviously, you have here atmospheric pressure, that is PA, and due to this, what happens? The fluid will rise, this liquid will rise in this tube. Let us assume that here the fluid rised or this water rise till height H, and inside water, whatever this height is there, that is, let us assume that H naught. So now let us assume that this is point B and this is point A. Okay. Point is A and point is B. Now what I am assuming, see, what is our principle? If velocity of flow at particular point is reduced to 0, velocity of fluid at particular point is reduced to 0, then the pressure there is increased due to conversion of kinetic energy into pressure energy. Yes, no? So now here you have velocity phi, but here velocity is 0. So this is what 0 velocity, but here you will get this kinetic energy converted into pressure energy at point B. Yes, no? Understand? And this is what your principle behind this pitot tube. Now, considering point A and B, considering point A and B, see here, using Bernali's theorem, now whatever this pressure at or between A and point B, no, here A point, there B point. So for A point, what is the pressure rate? Pressure at bottom means what? Pressure at top plus rho G H. So this is rho G H naught. This is what pressure here. Plus half rho phi square. This is equal to, this is atmospheric pressure only I am assuming, because here also you have atmospheric pressure only, that is PA, and plus rho G H plus H naught. That is what extra energy which is getting added, but here velocity is 0, and that is getting converted into potential energy or pressure energy, we can say, right? Now, what we are getting, this is PA plus rho G H naught plus half rho v square is equal to PA. This is also PA only, okay, plus rho G H plus rho G H naught. Okay. Now this PA and this PA, if we will transfer here and subtracted, then it will get cancelled. Even this rho G H naught and this rho G H naught also, if we will transfer and subtract, it will get cancelled, means 0 it will become. And what is left now? Half rho v square is equal to rho G H. This row and this row will get cancelled, and then v square is equal to 2gh. And if you want to find river velocity, this is equivalent to what? Root 2gh, where h is the height raised in the pitot tube above the water surface. Above the water surface in the sense river. Okay, right? Is that clear? Above the river water, we can say. Understood? Like that, we can find the
Yes, sir.
river flow velocity by using this Pitot tube. Understand? So note
Yes, sir.
down. Now next one, that is dynamic lift. Okay. Dynamic lift. So in that first one, that is lift on aircraft wing. Right. So all of you know aircraft wing, right? Even at least you know the bird, what you can say, wing. Yes, no, bird wing, you know,
Yes, sir.
it is
Yes,
something
sir.
like this. You can see here. Something like this. Yes, no, right? And now this is what airflow. This is what the airflow. There should be one particular angle for this also. Okay, that also we will see. Just wait. This what angle theta. Okay. And now see here. This white color you can see. Below this wing, whatever the velocity of air is V2. Okay. And whatever the pressure is there below this wing, that is suppose P2. Now above you have velocity V1. I will change the color. So this is what velocity above the wing is V1, and the pressure is what? P1. So see here, as this air is moving very fast, P1 is more, P1 is more above the wing. Yes, no, P1 is more, that is velocity is more above the wing. Okay, and that's why P1 is less. Now P2 is less, that is below the wing, below the wing, and that's why this P2 is more. Okay, yes, no, so that's why as this velocity is less below and pressure is more, that's why it will get lifted up. Okay, and the angle of chord or angle of attack, we can say, what is this angle of attack? The angle between chord of the airfoil and wind stream direction. And its value does not exceed 3 degree to 4 degree. Okay, for modern airplanes. Okay, for modern airplanes, we can say. Okay, you can write down it later. I'm just moving ahead. Okay, you write it later. So next one, when I will upload, no, that time you write. Next one. Now, according to Bernali's theorem, according to Bernali's theorem, P1 by rho plus half half rho V1 square. No, if there we have taken rho, we will not get rho no here. So half P1 square is equal to P2 by rho plus half P2 square, and therefore just transfer this term this side. P1 minus P2 by rho is equal to half, I am taking common, P2 square minus P1 square. What I did, I transferred this term this side, and just taken P1 minus P2, means subtracted, and just row down. Okay, so this is what your pressure difference, and therefore pressure difference P1 minus P2 is equal to half rho P2 square minus P1 square. Okay. Now, aerodynamic lift is what? Aerodynamic lift is equal to pressure difference into area of the wing, and that is equal to P1 minus, or just this is half rho P2 square minus P1 square. Already we have no P1 minus P2. So I'm going to substitute that only. Half rho P2 square minus P1 square into this area of the wing. Okay. So you are getting that is half rho A P2 square minus P1 square. This is what aerodynamic lift. Okay. Next one. The fractional increase in the speed of the air. The fractional increase in the speed of the air means direct I'm writing like this. That is P2 minus P1 divided by P average is equal to delta P by rho into P average square. Okay. Into, no, that's it. Yes, no. And here you have P average is equal to what? P1 plus P2 by 2. So V2 minus V1 divided by V average, which is equal to delta P by how you are getting this? You just see we have one formula. Delta P is equal to half rho P2 square minus P1 square. Yes, listen here. How you are getting this? So I am writing here 1 by 2 rho P2 plus P1 into P2 minus P1. And that's why this is what rho P2 plus V1 by 2 is what V average into V2 minus V1. Yes, no? And that is what this delta P. So delta P by rho into V average is equal to V2 minus V1. And that's why I got like this here, this V2 minus V1 by this whatever the fraction is there, no? Fractional increase in velocity. So that is what here I am getting. P2 minus P1 divided by P average. And already I have found out here V2 minus P1 value. You just substitute there delta P by rho into P average. This is what just V2 minus P1 value. And this 1 by P average again here. Yes. And that's why you are getting delta P divided by rho into P average whole square, and that is what fractional increase. Okay,
Should we
are you
rejoin?
understood? Yes,
We rejoin, sir.
no need. So like this you have, okay.
सर एक बार लास्ट स्लाइड दिखा दो ना सर.
Yes, this is your last slide.
1 minute sir.
and this is next one. I will upload this, don't worry. You can just immediately write down. I am uploading and sending you.